Thomas Wagner of NASA. He directs the agency's programs for glaciers, sea ice, and polar regions. And welcome, Mr. Wagner. Thanks for coming in. So first of all, how surprising, let's start with the thaw, the melt that occurred on Greenland itself. How surprising was this?
Complete surprise. So much of a surprise that one of the scientists who studied this thought there must be something wrong with his instrument.
So then you determined that this was for real.
Right, and what happened was this, we got some reports that there was melt going on all around Greenland, literally like so much water running off that it was washing out bridges and things, that there were runways that were on the snow that were having problems. And so what we did was look at the satellite records, which are great because they cover the whole ice sheet. And what we found pretty quickly was that it had melted, and it melted in places that we had never seen melt before.
On Earth, we have a lot of water locked up as ice. Particularly the poles, you get really big piles of ice, and we call those ice sheets. These ice sheets are great indicators of what's going on with our climate. So there's a lot of investigation. Are they melting? Are they not melting? Because if they do melt, they raise sea level, and that affects everybody in big ways. Here's a visualization showing the Earth and the areas in red that would be submerged with 6 meters of sea level rise. So 6 meters of sea level doesn't sound like very much, but it'll affect a very large part of the world's population and landmass. When we zoom in to finer spatial scales, it allows us to put a more human face on the sea level rise that could occur in the future. We can actually see individual communities that will be submerged by sea level rise. Science is never certain. What science is all about is trying to figure out what's probable, what's not probable, and to be really open with what the uncertainties are. In this case, we know the sea level was higher in the past. And we know that was because the Earth was warmer, particularly in the northern hemisphere, over the Greenland ice sheet. The big question is, how much warmer was it? And both our climate modeling and our paleoclimatic reconstructions suggest it's somewhere between 3 and 5 degrees C is the temperature by which a lot of Greenland will be melting fast. But to put it in a little perspective, 3 to 5 degrees, how long will it take us to get there? Just in the last 50 years, we've warmed up the Arctic by over 2 degrees. So we're more than halfway to 3 to 5 degrees. And sometime later in the century, we'll cross that mark. In our work, we don't know for sure where the threshold is beyond which the ice melting is inevitable. But we know it's coming, and if we don't do something about greenhouse gas emissions soon, we're going to cross that threshold, and future generations are going to have to deal with that big sea level rise.
Look at that, whoa!
There's so much energy here, that's the force of this water. What's the speed?
That peak's at 9.4 miles an hour.
That's really moving. This must be about 1,000 cubic feet per second. This is more melt than I was expecting.
On a scale from 0 to 10, how serious is this melt issue?
It's an 11.
In just one day, nearly 42 million litres of fresh water drained down this one moulin alone. And Jason believes there are hundreds, possibly thousands more of them on the Greenland ice cap. The data sends a chill up Basil's spine, and it's not from the cold. At this rate of melting, Greenland is losing enough water each year to cover Germany a metre deep.